Oh, hello class. Welcome to complex numbers. This is our notes 2.4. It's a good one for you, just like they all are. They're all good ones. Let's talk about what is special with complex numbers. Is now we have imaginary numbers. All right, it's called complex because, well, it's imaginary. That's a complex thing to think about, right? So it's not real, it's imaginary. So this is the definition of imaginary right here. Is I is equal to the square root of -1. So this allows us to have negatives in the radicals. Therefore, what does I squared equal? -1. If we square I, we get -1. And this one right down here is just kind of showing you what happens. So if you have a negative inside the root, all you do is you take the negative out. The way that I do it is I do this. I do square root of -1, and then I'll do a square root of 9, and then from there I can simplify it. Got it? Okay, sure, you all said. Perfect. Okay, let's do a quick review thing here. So, what do you do for this right here, for root 12? What I do is I find out a perfect square that goes into root 12. So like I'm looking for the numbers like, well, 1's not going to help me. But like 4 and 9 and 16 and 25 and 36, I look for those numbers. Which one of those numbers goes in here? So our root 4 and leads with a root 3. What is root 4? 2 to root 3. Got it? And for this one right here, what perfect square goes into 72? 9 does. I agree, but then that's with root 8. I feel like I can go bigger. 16. 12. No, 12's not perfect. What's that? Someone said it, I thought. 36. So I can do a square root of 36, and I can do a square root of 2, which becomes 6 root 2. All right. Okay. Is this focused very well? No? Thanks for telling me. Oh, is that better now? Is that a question back there or a stretch? Okay, so let's talk about adding, subtracting, multiplying, dividing complex numbers. Write the statement so it's in standard form. So A plus BI, which means that the imaginary needs to be last. So that's kind of important. So let's look at the first one. What simplifying can I do? What about the radical? So this is like it's a -1 and then a square root of 25. What do those both equal? 5i? Why is it 5i, or why do I have to zoom in? No, why? Why is it 5i? Because what's the square root of -1? I. What's the square root of 25? Okay. 5. I plus the I last because I have to. And then what number's in front? So it's -8 plus. You're saying plus or minus? I've never heard of that before. Does the school make up math or something? I'm going to hit pause real quick. Alright, everybody. We are resuming our notes after a quick little mishap. Stop a fight in here. The fist fight. I had to run in. I had to stop it. But we're all good now. So if you see any blood dripping on the paper, I'm sorry. I'm working on it. Okay, so for number 2, this is 17x minus square root of -18. So the only thing I can simplify is that -18 in there. So let's break this down into what square roots can I break it down into? -1. What else? Can I break up the 18 though? Into root 9 and root 2. So I didn't touch the 17x, it's still there. Minus the root 9 becomes a 3, get a root 2, and then I put an I in the back, like that. Some teachers in the past would be like, oh, that's 3i root 2. That bothers me. You know why that bothers me? Because I'm a literal person. This says I has to go last, so I put I last. So there's I. So I like this one better. Okay. So if there's ever a radical, I put a little space between it, so I know that the I is not underneath the radical. I'm not trying to fool anybody, but I like to put the I last. All right. So for number 3, now we're going to be adding, subtracting, the same thing, by the way, in terms of the idea here. You can only add numbers with numbers and i's with i's. That's it. You can't add numbers and i's together. They're separate entities. So let's add the numbers together. What's 4 plus 1? Oh yeah, that was really hard. What's 7i plus negative 6i? It's real tricky here, folks. Real tricky. Oh, okay, this gets tricky. This throws people off. Multiplying. So when I go ahead and multiply, I have to do each one appropriately. So 2 times 4 is 8. 2 times 3i is negative I times 4 is, I'm going to line those up like that. I'm going to stack them. And then negative I times 3i is minus 3i squared. So I'm going to get 8 minus 2i. What does this I squared become? So it becomes negative 1. So if I have an I squared, just change my sign. So this becomes a plus 3. I can't do math. Just trying to see who's paying attention. Oh, there's a plus sign there. You just can't see it. I'll darken it in for you. Yeah, because is this the final answer? No. So let's make the final answer. 11 plus 2i. Is this plus clear enough for you this time? Yeah, good. No? We said no. Jerk. I'm going to pick on my teacher the whole time. Make him cry when he gets home. Okay, let's talk about conjugates. I don't know. They just throw conjugates in here randomly because we're going to use conjugates in a little bit. So the whole idea of doing a conjugate is the middle terms get canceled out. So at any time there's like square roots involved or complex numbers involved, if you want to get rid of an I term, multiply by the conjugate because then it goes away because the middle terms go away. You see how there's no more i's anymore? It's going from this step to that step. All of my i's go away. So you can turn imaginary numbers into real numbers by multiplying by the conjugate. Now the only problem is multiplying by the conjugate more than half the time is an illegal thing to do. You can't just do it. Like, I'm just multiplying by the conjugate. In the math world, you need to balance it out somehow. So typically, when we have fractions, that's when we multiply by the conjugate because we just want to balance it out. So I guess we're just going to practice multiplying by the conjugate, and then we'll actually apply it. So in the first one, how do I know this is the conjugate? Very good, class, because they are opposite signs. Same terms, different signs. 3, 3, 2i, 2i, plus minus. So when I go through, do I need to do the middle terms? You don't need to. If you want to, because it makes you feel better, go for it. I'm all about positive imagery, making yourself feel better. So 3 times 3 is 9, and then I'm going to get a minus 6i plus 6i, and then minus 4i squared. Middle term, woo, goes away. 9 plus 4, which gives me a 13. Why is that a plus 4, you might ask? I squared changes the sign.
Hold on. I zoned out for a little bit.
Yeah, we'll wait for you because you zoned out.
Yeah, actually I'm confused. Like I was looking at my paper, and the next thing I knew it was all.
So in other words, I hit pause, and mentally I hit pause on the video, did all the work, and then hit play. And it just magically appeared.
Yeah.
Okay, I'll walk through it again. 3 times 3 is 9, and then the middle terms are going to cancel out because they're the same thing, just opposite signs. So you get negative 6i and plus 6i, and then you get negative 4i squared, and the I squared changes signs into a So it's a minus 4, negative 1 turns into a plus 4. Are you good now? I'm glad we can all get back together. All right. Number 2. What's the conjugate of 1 plus I? So we're going to do 1 plus I times 1 minus I. So you're going to get 1 plus I minus I squared, which becomes 1 plus 1, which is 2. Here's what that gets everyone all the time. What's the conjugate of 5i? Oh, you people aren't tricked. So the conjugate of 5i is negative 5i. So this is the conjugate. So what do you get from this? Negative 25i squared, which is 25. Hey, here's a trick question for you. What's the conjugate of 2?
There is no conjugate because it doesn't have an I.
Very good. There is no conjugate of 2. The conjugate of 2 is 2. Because the conjugate only goes on a radical or a complex number. So, if I don't have a radical or complex number, there is no conjugate. Very good. You're also SMRT. So smart. Okay. Let's write this in standard form. In order to write this in standard form, you're not allowed to have a complex number on the bottom. It's not allowed. It's naughty. It's bad. I tell my kids all the time, hey, you're being naughty. I'm not being naughty. Yes, you are. You're throwing my remote controller around the room. Don't do that. Daddy wants to watch sports. Okay, so how do I get rid of that imaginary number on the bottom? Multiply by the conjugate, which is? What you do to the bottom, you have to do to the... Okay, so let's do the top real quick. I'm going to get 6 minus 7i plus 12i minus 14i squared. On the bottom, I get 1 minus 4i squared. I'm skipping the middle terms. Are we cool with that? Fine. I'll do the middle terms to make you all happier.
No. You don't have to. I just don't understand what you mean.
Well, because the middle terms are plus 2i minus 2i, which is canceled out.
Oh, then you don't have to do that.
Then you have to do them. Make sure you watch the video to miss what you pick up what you missed. So on the top, how does the top simplify? I get 6 minus plus 5i. And then that negative 14i squared turns into a plus 14. So I simplified that, and I simplified that. We good? On the bottom, these go away. So I get 1 plus 4. So now I get 20 plus 5i all over 5. This is not an A plus or minus BI form. I have to get an A term by itself and then a B term by itself. So what if I just divide each of these by 5? Is that legal? Yes, it is. Perfectly legal. That's how you do math. So what's 20 divided by 5? Plus 5i divided by 5 is? Final answer. I was tutoring somebody yesterday in calculus, and they didn't know this rule, and so I had to explain it. Well, I mean, he knew the rule, but he forgot about it. Because technically, this is the same thing as 20 over 5 plus 5i over 5. Do you agree that those are the same things? We're just going, sure, we're just going backwards. You know how when you add fractions, you need the same denominator, and then you can put them together? We're just pulling it apart. So, kablamo, answer. Let's move on. Okay. Alright, here we go. Principal square root of a negative number. By the way, I got a problem. What's my problem? My paper is blue, and that's not my problem. It's green. I have a problem with how this is written, the top.
Oh, it has
This is just how I am. It's the kind of guy I am. I like the eyes in the back. because I'm such a literal person, I like to follow the rules exactly. So it says a plus bi. I want I last, not like in the middle. So if you have a root negative 3, it's the same thing as root 3 I. Do not put that I underneath the square root. You're going to have a bad time. So the principal square root of negative 3 is root 3I. So find the principal square roots of the following. So negative 25. What's the principal square root of negative 25? All you have to do is take the square root of it. So let's do that. And you're going to get 5i, you said?
Yeah.
What about this guy right here? Square root of negative 63. So you're going to say root 63i. I agree with that to an extent. Is that fully simplified?
No.
You can take out a what? A root 9 and a root 7, which becomes 3 root 7i. Is that hard to read, by the way? Or should I turn the light off? How does I turn the light off? Does it turn yellow again?
It's good. You're good.
Is that better?
No, I like the other one better.
I'm hearing 50-50. You like this way or the other way?
The other way.
This way, the other way.
No, the other way is brighter.
Yeah, if I put it up higher though, and the light is not beaming on it, we're good.
Why do you like that? The other one is dull.
Oh, wow, we're picking out people's opinions on what a screen looks like. That's the wrong opinion to have. Quite frankly, to me, this is perfectly zoomed in. I like that picture. It's my favorite. No opinion. Oh, now I unzoomed in. Okay. Letter C. Take the square root. What things are to pop out here?
9.
9.
9.
A 9. No, the X does not pop out. The X stays in. Is there any way to take the X out?
No.
Stays in. Loser. And then an I. That's it. Now, hey, watch this. Let's watch this. What if I had X squared?
Yes.
Now the X would come out. Yes. How many pairs of X's come out?
1.
Just one. So I would get 9xi. What if it was a 4? How many pairs of 4 are there?
2.
There's 2. So how many X's come out? What's that? Somebody asked, what if that was a 5?
No one asked.
Sure, I would love to answer that question for you. How many pairs of X's come out of 5?
9.
2 pairs come out.
So you leave an X in there.
Yeah, poor guy. It's like breaking out of jail. You need pairs to break out of jail. You got 5 people. How many people are getting out? 4 are getting out. One is left in there. You need it's pairs. You need pairs to break out of this special jail called square root.
Like to get out.
Yeah, okay. It's talking about how to get out of jail. I'm going to record this too. So you need a pair. And you need to watch the movie Shawshank Redemption. Done. Which is a good movie, mind you. Very good movie. Very good movie. What's that? I believe we cannot talk about that. It's rated R.
It is not rated R.
Yeah, it's rated.
14.
It's what?
TV 14.
It should be a lot higher than that.
It's TV mature. Maybe. It is definitely not rated R.
Okay. Let's solve the quadratics. There are 2 different ways to do this. You can either solve for x right off the bat, or use the quadratic formula, or because I'm assuming we can't factor these because we're doing complex numbers. So obviously it would be like, can I factor it? This one's a no. Why can't I factor this one? If it was a minus sign, we're good to go. 2 choices now. You can isolate the x or do the quadratic formula. It's probably easier to isolate the x because there's only one x term. So let's get the x by itself by doing what? Subtracting the 4. So we get x squared equals negative 4. How do we get the x by itself now? Anytime we take the square root of an equal sign, we always get two answers. Because x equals plus or minus. Anytime you take the square root and there's an equal sign, you get two answers. That's why there's a plus and minus here. Plus or minus? 2i. Let it be. Does this factor? If it did, we didn't learn anything. Oh, the factor is great. We already knew to do that. This one does not factor. Okay, so let's just pretend we tried for a long time. It doesn't factor. Your combinations have to be 3's in the front and 5's and 1's. So you can't get a negative 2 from that, from they're both being positive, from being the same sign. So it's not going to happen. So you have to do the quadratic formula. To remind you, it is negative b plus or minus the square root of b squared minus 4ac all over 2a. If you want to sing a song while doing that, not in my classroom. Do it at home.
I can't remember.
There's a story I could tell you. It's like rated mature though. I don't know if I can say it.
Pause the video.
Yeah, I'm not going to tell you the story. No. Why would I just terribly. No, I will not tell you that story. Let's just move on. So let's go ahead and plug in these values. So all the coefficients. So a is 3. Coefficient of the b is going to be negative 2. Coefficient of the c is just a constant 5. Let's go ahead and plug it in. So x equals a negative 2. By 2. Plus or minus square root of negative 2 squared minus 4 times 3 times 5 divided by 2 times 3, which is going to be 6. So inside my radical, what do I get? 4 minus 60. Is that correct? 4 minus 60? Which is a root negative 56. And what is a negative 56? Can you break that down? Does 16 go into that? No. 4. 4 does. 4 the biggest number though? 4 and 14? 4 and 14? So negative 1, 4, 14, so it becomes 2 root 14i. So I get 2 plus or minus 2 root 14i all over 6. Is this a good final answer? What did I do wrong? Oh, it's fast?
Yeah, you're going awfully fast. Yeah, can you just redo it?
Yeah, hold on. Let me just hit pause and hit play again. So all I did is I just did a bunch of side work here, simplified the radical. That's all I did. So I got 4 minus 60, which is negative 56, which is 2 root 14i. If you don't know that, just divide it by 4, and you're good from there. And if you can't break down 14 anymore, then you're fine. Are we good now? You can't even see. There's nothing I can do. Are we good now? You just let's go write down the final answer. I'll worry about it later. Oh, thank you. It's blurry. I turned this light off. It's annoying. Does that make it better? Okay. Okay, I'm not done yet, by the way. But this is where we're at right now. Oh, darn, we're not done yet. Okay, any questions how 2 root 14I appeared magically? You just do math. Come on, just do math. Okay, so now, I want to break this up into 2 fractions. So now it's an a plus or minus bi form. Can I simplify it? 1/3 plus or minus root 14 over 3. Yeah. Okay. Hey, before I do the next set of notes real quick. What?
No, because the I is always at the end.
The I is always at the end. Yes. It was a negative b, so it had a negative 2. What's that? No. I don't know what you just said. I was going to say no. Yeah, I mean, like, you could write it like this. This is the same thing. This is probably what your teacher wrote last year. That's the same thing. Well, we have our opinions, but I'm right. That's what I tell my wife all the time. You have your opinion, but I'm right.
What does she say?
She says, I'm going to the lawyer to get some divorce papers. I'm like, no, you're good. I'm kidding, we've never done that. I just sleep on the couch. Okay, before we go on this last section, real quick. I equals I. Duh. I squared equals -1. I the third, what do you think that one equals? Well, isn't it I squared times I? Right above it. So isn't it I times -1, which is -I? And what's I to the 4th?
Okay, explain how that's negative I.
Because I to the 3rd is equal to I squared times I. Do you agree? I squared is -1 times I, which is...
And then I to the 4th is I squared times I squared.
So, if I were to draw a little bit of a pattern here... everything starts to repeat. Because I to the 5th would be I to the 4th times I, which is just I. I to the 6th is -1. It starts to repeat. Okay? So I draw this make this little circle. Because this is equal to -1, this is equal to -I, and then this is equal to 1. Okay, so if I wanted to know what I to the 25th is, all I do is I start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. What's the answer? I. I to the 25 is I. I will get more into depth than that. It'll be going, oh my god, that's so magical. I don't know how he did that. So we can do it 64 times. Is there a shortcut? Divide by 4, because they cycle on in fourths. Remainder 1 is here. Remainder 2 is here. Remainder 3 is here. There's no such thing as remainder 4. So no remainder would be the 4th one right here. Okay? So if I were to do 4 divided by 64, how many times does 4 go to 64? 16 remainder, 0. So it's like I to the 0 power. What's anything to the 0 power? 1. So guess what? Equals 1.
I can't see.
Nobody can.
Why does 25
Now let's do the 25 one real quick. What's 4 divided by 25? The problem we just did. Get 6, 24, remainder 1. So it's I to the first.
This doesn't make sense.
All right, I'm 50% accuracy rating here. I swear, half of you are just saying it doesn't make sense, and the other half are like, no clue in the world. Okay, so about 35. Let's do 4 divided by 35. Well, so it's going to be 8 remainder. Remainder 3. That's I to the third. What is I to the third?
Negative I.
Negative I. Try the last one on your own. Do 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 boom boom. Okay, remainder 2, which means it's I squared, which is negative 1. Oh, and we didn't do the first one. What's I to the fourth?
1.
Cool.